We're going to start off with step one. And step one is to find those initial conditions. And the first part of finding initial conditions is to draw it for time less than 0. And our goal is to find I sub L and V sub C no matter what you're asked to find. So for time less than 0, is the switch open or closed?
Closed.
Closed. So we've got this 4 ohm resistor, and our capacitor becomes an open VC. Now, look, the moment that I defined these things that aren't in the original circuit, I better define VC, and I better also define IC if I'm going to use those constitutive equations. And of course, the current always leaves more negative. So I'm going to do the same thing. I've already defined I sub L, so I have to define my V sub L in that direction. And now that I've got it defined in my original thing, now I can start using VCs without worrying that I'm going to accidentally change my directions. So the inductor looks like a short, and this is my I sub L, and that's my V sub C. So just by inspection, can you quickly tell me what my I sub L is? Ask where does the current flow? There's only one current loop. It can't go over the the open, so it's got to go that way.
Is it 1 amp?
Divided by 6?
Yeah, it's just 10 divided by 4 plus 6, and it's got to go through the 4 ohm resistor, through the 6 ohm resistor, so therefore I sub L is equal to 10 volts over 4 plus 6 equals 1 amp. Okay, and now we need to find out what V sub C is. Can we add any of the voltages to this? How much voltage is across the 6 ohm resistor?
6 volts.
6 volts. So if there's 1 amp flowing through it, there's got to be 6 volts across it. How much voltage is across the 3 ohm resistor?
0.
Why 0?
Because it's an open.
Because it's an open. So since there's no current that can flow through it, by Ohm's law, there can be no voltage across it. Okay, so armed with all this, can someone tell me what our V sub C is?
6 volts.
It's 6 volts. And that's because we have 6 volts between these 2 points. So there's no voltage drop across here, so there's got to be 6 volts across V sub C2. So just by looking at it, we can see it's equal to 6 volts. And we're going to keep those 2 results highlighted, prepared for our next section, or part B. So for part B, we're going to say, we're going to draw it for time equals 0 plus. We're still trying to find initial conditions, but now we're going to find the initial conditions of what we're asked for, which is so different than what we did in first order, which said we don't care what we're asked for. We're always going to find I sub L and V sub C. Here we're finding I sub L and I sub L prime at 0 plus, since that's what we're asked for. And so we have to start off by drawing it for time equals 0 plus. For that time, the switch is opened. And so the only thing that really interests us is the capacitor is the right side of this thing. This is the only place where current could be flowing. Is everybody okay with me combining these 2 resistors together, the 6 and the 3, to make a 9? They're in series, and it doesn't matter what order we put them. I mean, just as a little aside, if you had back from an earlier class, if you were just interested in the current here and you had R1 and R2, I hope it's clear that you could combine those 2 guys and just drive on. So the fact that all the current has to go through the 6, through the inductor, and all of it has to go to the 3, it sees those 2 just as far as the current's concerned, as just in series. So does anyone want to talk more about what allows us to combine those 2 resistors in series?
I would after class, perhaps. Or whenever there's time, just so we can.
Well, no, if you're not sure, Dom, let's talk about it right now. If you've got, so here's the Thevenin. The question is, what is the Thevenin equivalent of this? And you don't right now have enough tools in your toolbox to answer that question, but if we just care about what's outside those two terminals, do you feel okay about saying that we can switch any two components that we want to? Here's our L, here's our R1, and here's our R2. So what we did right here is we just switched the positions of our R1 and our L. Do you feel intuitively comfortable that we're allowed to switch the components, any two components?
Just because the current's gonna flow through it anyways.
The current's going to flow through it anyway, so you can certainly switch. It's just like the associative property of addition. You can switch those things around.
Okay, thank you.
And then if you believe that, then let's just redraw it now. Like this. And we've already shown that that if you're only interested in things outside these two resistors, the Thevenin equivalent of those two resistors is exactly equal to their sum. Is that thumbs up with everyone? Okay. And the same thing is true, by the way, for stuff in parallel. So if you've got stuff in parallel, you can move them around. You can, if it made you feel better, you could move this capacitor to the end, and it doesn't change anything in your circuit. And you can combine these two guys together, and it doesn't change anything. So you can move things. You can move the order around in parallel circuits or in series circuits. Now, you can't do it if it's neither in series or parallel. You can't move this guy with that guy. That's not allowed because they're not in series or parallel. All right. So thumbs up with everybody about what we did. Excellent.
Sir, I have one question, not regarding what you just drew, but
yeah.
The 3 ohm resistor that was below the capacitor, we can just ignore that because it's 0 volts, right? Or is there another reason that we left that out on this?
So we're actually not, I don't like the word ignoring anywhere, because when we start saying, when can we ignore things, it starts to sound sort of like magic rules. You know what I mean? And I know I sometimes use that too in its poor form. What we're doing is that we're saying, we're simplifying. What we're doing is we're saying, if we've got this 3 ohm resistor, and if for some reason we know what the voltage is across it, let's replace it with let's replace it with a voltage source. Anytime you know what the voltage is across any component or current is through any component, you can always replace it with just the equivalent voltage source or current source. And now what's a 0 volt voltage source? It is a wire.
All right, thank you. That makes sense.
And so that's the sort of the rigorous version. The unrigorous version is, yes, I just ignored it because it was 0 volts. So I know in my head it's a wire, but there it is with sort of the right way to think about it, to justify it, I should say. All right. So now let's move on with our IL is clearly 1 amp. How do we figure out what our I sub L prime is? The only way to get our primes, whether it's a voltage or a current or anything, is to look at our constitutive equations. It's I sub C is equal to C dV dt, and V sub L is equal to L di dL. So those are 2 constitutive equations. Which of these can we use to find our I sub L prime? Well, it's clearly that one. Our homework threw out some other more complicated versions, but here we're clearly going to use this thing. So we're going to say I sub L prime at 0 plus is equal to 1 over L times V sub L at 0 plus. So this is all at 0 plus. Well, 1 over L is just 2. And V sub L, how the heck do we figure out what our V sub L is? We have to define our V sub L as this. Do we know what, if we're looking for voltages, let's look for all the voltages we can find. Do we know the voltage across the 9 ohm? If we knew what the voltage was across the 9 ohm, then we could use KVL around the outside and find V sub L. We know all the voltages here, here. We just don't know the voltage here, and we could solve it. But what's the voltage across the 9 ohm?
So since there's 1 amp flowing there, wouldn't it be 9 volts?
So it's got to be 9 volts since there's 1 amp. So by Ohm's law, has to be 9 volts. So now we can write, if you're good, you can just see it. But it's easy to get signs wrong, and so let's just write it up. Starting at this negative side of our 6 volts, we get -6 plus 9 plus V sub L equals 0. So therefore, V sub L has got to be equal to -3 volts. And now we can use that equation down here to find out that the derivative of the current is equal to -6 amps per second. So just like a current is 6 amps, a derivative of a current is a change in current. So it's amps per second. Another way to look at it is that if you take the d over dt of I, the units would have to be whatever the units of current is, which is amps, and the units of d over dt, well, there's no units of d, but dt, that's seconds, so it's amps per second. So our answer is -6 amps per second, and now we found, and now these are our true initial conditions. Questions about that step? So all that was just the homework.